Wish you a very good morning to all. So we are in physics chapter 2, magnetic effects of current. So in first part we have seen some of the NCERT questions, and today we are going to discuss exercise questions which are there in NCERT. So that are always crucial for your exam. So we will discuss that NCERT question answers from NCERT solution. Now these are the NCERT question answers. Which of the following correctly describes the magnetic field near a long straight wire? So here answer is D. The magnetic field lines produced around a straight current carrying conductor are concentric circle. Their center lie on the wire. So answer is D. Next question. The phenomena of electromagnetic induction is. So here answer is C. Producing induced current in a coil due to relative motion between a magnet and the coil. So here answer is C. When a straight coil and a magnet are moved relatively to each other, a current is induced in the coil, and this phenomena is known as electromagnetic induction. Next question. The device used for producing electric current is called, it is generator. So an electric generator produces electric current. It converts mechanical energy into electrical energy, means electricity. Question number 4. The essential difference between an AC generator and DC generator is. That answer is D. AC generator has slip rings while the DC generator has a commutator. AC generator has slip rings and DC generator has commutator. So here we can say that an AC generator has two rings called slip rings. A DC generator has two half rings called commutator. This is the main difference between both type of generators. Next question. As the time of short circuit, the current in the circuit, generally when the two marked wires of an electric circuit touch each other, the amount of current that is flowing in the circuit increases abruptly, and this causes short circuit. So answer is C. Increases heavily. Question number 6. State whether the following statements are true or false. First, an electric motor converts mechanical energy into electrical energy. It is false. Second, an electric generator works on the principle of electromagnetic induction. It is true. Third is, a generator is electric device that generates electricity by the rotating a coil in a magnetic field. So that is why we can say that electric generator works on the principle of electromagnetic induction. Third is, the field at the center of a long circular coil carrying current will be parallel straight lines. So it is false. So a long circular coil is long solenoid. The magnetic field line inside the solenoid are parallel lines. Question D. A wire with a green insulation is usually the live wire of an electric supply. So it is false. A live wire has a red insulation cover, whereas earthing wire has green insulation color in the domestic circuit. Question number 7. List 3 sources of magnetic fields. So as we have discussed in our topic magnetic field, 3 sources of magnetic fields are current carrying conductor, permanent magnets and electromagnets. Question number 8. How does a solenoid behave like a magnet? Can you determine the north and south poles of a current carrying solenoid with the help of bar magnet? Explain. So already we have seen this type of question. A solenoid is a long coil of circular loops of insulated copper wire. Magnetic field lines are produced around the solenoid when a current is allowed to flow through it. The magnetic field produced by it is similar to the magnetic field of a bar magnet. The magnetic field lines produced in a current carrying solenoid is, you can see in this figure. So in between the solenoid there, and how the magnetic field is produced from north pole to the south pole, and inside it is south pole to the north pole. So in the figure you can see, when the north pole of a bar magnet is brought near the end connect to the negative terminal of the battery, the solenoid repels the bar magnet. Since like poles repel each other and the end connected to the negative terminal of the battery behaves the north pole of the solenoid and the other behaves as a south pole. Hence the one end of the solenoid behaves as a north pole and other hand behaves as a south pole. And that is why the magnetic field is produced. Question number 9. When is the force experienced by a current carrying conductor placed in a magnetic field largest? The force experienced by a current carrying conductor is the maximum when the direction of the current is perpendicular to the direction of the magnetic field. Question number 10. Imagine that you are sitting in a chamber with your back to one wall, an electron beam moving horizontally from back wall towards the front wall is deflected by a strong magnetic field to your right side. What is the direction of the magnetic field? The direction of the magnetic field is given by the Fleming's left hand rule. The magnetic field inside the chamber will be perpendicular to the direction of the current, means opposite to the direction of the electron, and the direction of the deflection or force either upward or downward. The direction of current is from the front wall to the back wall because negatively charged electrons are moving from back wall to the front wall. The direction of the magnetic force is rightward. Hence, using the Fleming's left hand rule, it can be concluded that the direction of the magnetic field inside the chamber is downward. Question number 11. This question is very much important for your evaluation too and most of the exams. So please careful and concentrate. Draw a label diagram of an electric motor. Explain its principle and working. What is the function of a split ring in an electric motor? So first of all, it is mentioned draw a label diagram. We have to draw this diagram, and after that we have to write the principle and working. An electric motor converts electrical energy into mechanical energy. It works on the principle of the magnetic effect of current. A current carrying coil rotates in a magnetic field. This follow the figure, you can see the simple electric motor that you have to draw. In that north pole and south pole in between, that diagram must include the labeling. Where is the splitting ring, where is the commutator, that all things you have to mention. Now here, when a current is allowed to flow through the coil MNST by the closing the switch, the coil start rotating anti-clockwise. This happens because a downward force acts on length Mn and at the same time an upward force acts on length St. As a result, the coil rotates anti-clockwise. The current in the length Mn flows from M to N and the magnetic field acts from the left to right, normal to length Mn. Therefore, according to Fleming's left hand rule, the downward force acts on the length Mn. Similarly, current in the length St flows from S to T and the magnetic field acts from left to right, normal to the flow of current. Therefore, an upward force acts on the length ST. These two forces cause the coil to rotate anticlockwise. After half of the rotation, the position of Mn and St interchange. The half ring D comes in contact with brush A and half ring C comes in contact with brush B. Hence, the direction of the current is in the coil MnST get reversed. So, here reverse direction also there. The same thing, the current flows through the coil in the direction T, S and M. And the reversal of the, in place of T, S, M, you can utilize A, B, C, D also. So, that also allowed, which is given in the textbook. The reversal of the current through the coil MnST repeat after each half rotation. As a result, the coil rotates unidirectional. The split rings help to reverse the direction of current in the circuit. These are called the commutator. So that question is very crucial for your coming exam. Name some devices in which electric motors are used. Some devices in which electric motors are used, that is water pumps, electric fans, electric mixers, washing machine. These are the some examples where the electric motor are used. Question number 13. A coil of insulated copper wire is connected to a galvanometer. What will happen if a bar magnet is pushed into the coil, withdraw from inside the coil, held stationary inside the coil? So 1, 2, 3 possibilities are given. So in that, a current induced in a solenoid if a bar magnet is moved relatively to it. This is the principle of electromagnetic induction. So first case, when a bar magnet is pushed into a coil of insulated copper wire, a current is induced momentarily in the coil. As a result, the needle of galvanometer deflects momentarily in a particular direction. Second case, when the bar magnet is withdrawn from inside the coil of the insulated copper wire, a current is again induced momentarily in coil in the opposite direction. As a result, the needle of the galvanometer deflects momentarily in the opposite direction. Third case, when a bar magnet is held stationary inside the coil, no current will be induced in the coil. Hence, the galvanometer will show no deflection. So, here in three cases, the galvanometer shows the deflection in first two cases, and third cases there is no deflection in galvanometer. Question number 14. Two circular coil A and B are placed close to each other. If the current in the coil A is changed, will some current will be induced in the coil B? Give the reason. Two circular coils A and B are placed close to each other. When the current in coil A is changed, the magnetic field associated with it also changes. As a result, the magnetic field around coil B also changes. This change in the magnetic field lines around B induces an electric current in it. This is called the electromagnetic induction. So, reason for this question is electromagnetic induction. Question number 15. State the rule to determine the direction in three cases. First, magnetic field produced around a straight conductor carrying current. Force experienced by the current carrying straight conductor placed in a magnetic field which is perpendicular to it. Third, the current induced in a coil due to its rotation in a magnetic field. So, answer if you think, that is Maxwell's right hand thumb rule. First is Maxwell right hand thumb rule. Second is Fleming's left hand rule. And third, it is mentioned induced current, that is a Fleming's right hand rule. Now next question. Explain the underlining principles and the working of electric generator by drawing a label diagram what is the function of brushes? The electric generator converts mechanical energy into electrical energy. The principle of working of an electric generator is that when a loop is moved in a magnetic field, an electric current is induced in the coil. It generates electricity by rotating a coil in a magnetic field. And you can see the figure, and that is a simple example of AC generator. So North Pole and South Pole in the brushes are there, split rings are there. The direction you can see A to B brushes are there, C and D two split rings are there, and X, that is axial, G, that is galvanometer. So if axial X is rotated in clockwise, then the length Mn moves upward while length St moves downward. Since the length Mn and St are moving in a magnetic field, a current will be induced in both of them due to the electromagnetic induction. Length Mn is moving upward and the magnetic field acts from left to right. So that is the same principle in the electric motor what we have seen. So here we can say that the direction of the current in the coil is MnST, and then after it will change into TSMN. So it will be reverse. So here to get that unidirectional current, instead of two slip rings, two split rings are used, as you can see here. So in the arrangement, brush A always remain in contact with the length of the current coil that is moving up, whereas the brush B always remain in contact with the length that is moving down. And the split rings C and D act as a commutator. The direction of the current induced in the coil will be MnST for the first rotation, and second rotation it will be changed, that is TSMN in the second half of the rotation. So, and that is why unidirectional current is produced from the generator called DC generator. This current is called AC current. Now next question, when does an electric short circuit occur? So here, if the resistance of an electric circuit becomes very low, then the current flowing through the circuit becomes very high. This is caused by the connecting too many appliances to a single socket, or the connecting high power rating appliances to the light circuit. This is result in a short circuit or overloading. That is also a case for the electrical short circuit. When the insulation of live and neutral wire undergoes wear and tear and then touches each other, the current flowing in the circuit increase abruptly, and the short circuit occurs, or overloading also one of the case. So that also you can include. Question number 18, what is the function of an earth wire? Why it is necessary? Earth metallic appliances. The metallic body of electric appliances is connected to the earth by means of earth wire, so that, and that is generally green color, so that any leakage of electric current is transferred to the ground. This prevents any electrical shock to the user. This is why earthing of electric appliances is necessary. So all the question answers which are there in your NCERT we have discussed in the second part of this video. So this chapter is completed. If any doubt would be there, we will discuss later on. So thank you and have a nice day. In our next video presentation, we will begin with the chemistry chapter. So thank you and have a nice day.